Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wassalatu wassalamu ala rasulullah, amma ba'du. Alhamdulillah, in this morning we can continue our lesson. And is today is a holiday in your country, or maybe tomorrow or yesterday, or there is no holiday. Right. Okay. So let's continue our lesson in this morning. So okay. Okay. Now let's begin our lesson with praying together. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Allahumma inna na'udzubika min ilmin la yanfa' wa min qalbin la yakhsha' wa min nafsin la tashba' wa min da'watin la yustajabu laha. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza syi'ta sahla. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. All right. And by the way, do you know about the place of IOI in this year? Do you know about the updates? In the last information, so the place of IOI is still in Bolivia, but in the different city, which is in Sucre, and this is the other capital city of Bolivia. So the unique thing is Bolivia has two capital city. La Paz is one of that two cities, and Sucre is the other one. All right. So maybe we need to change our display picture in our Discord group, maybe. Okay. But it is not too important. All right. So let's continue. We already discussed about powerlifting, and I think it is better if we go to the next topic. And I think Fenwick tree is also related to powerlifting, because one of the idea in Fenwick tree is powerlifting, right? So we can find the flower bound in Fenwick tree in just log n using powerlifting. Do you know about that trick? I think we have discussed about Fenwick tree in some lesson before it. Okay, yes, that's it. And maybe you already solved some of the problem. Okay, I think we have ever discussed about problem G. That's why Abdullah can solve it. Alright. So have you solved about have you solved problem F about this one? Alright. I think it's better if we discuss it. So if you solve this, you can challenge your seniors. Alright. Okay. So let's discuss what is the solution for this problem. So in this problem, given n distinct items and for each items, it has some prerequisite, which is we need to buy those items before this item. Alright. For example, in the first problem, so before we buy the first item, we need to buy the second item. And then the second item hasn't any other item. So we can buy this in the first time. Alright. After that, the third item has to has two items before it. So we have to buy second item and fourth item before this. Alright. And we have to buy second item before the fourth. Alright. And then what shall we do? We want to buy all of the item in n days because there are n distinct items. And you know, in one day, we can only buy exactly one item. Right. So we will buy the item one by one for n days. And we want to find the lexicographically smallest. Alright. So do you know how to do that? How to find the lexicographically smallest? Do you know about this problem? I think the problem is quite popular, which is about topos sort. Yes, lexicographically smallest from the order of both item. Chrono Chronologically means based on the order of the time. So what is the first time we bought, or what is the first item we buy, and then what is the second item we buy, and then what is the third item we buy, and so on. So it is listed in chronologically. It means based on time. Right. At first, please don't care about this. Don't care about the index. If there is no rule about this, how to solve this? For example, for this graph, at first we can take 2. After that, just take 1, and then take 4, and then take 3. Is it correct? Is it the lexicographically smallest? Yes, alright. So, do you know how to find the lexicographically smallest? Do you know about topo sort? Yes, topological sorting. And we want to find the geographically smallest. So do you know how to do that? Not just topo sort, but we want to find the smallest one. So how to do that? Any idea? Yes, that's it. We can use pip or parity cube. Alright. So at first we have to start the degree of each nodes, or in degree for each node, and then we only can buy a node that the degree is equal to 0. So if there is a node that the degree is equal to 0, just put this into a priority queue. So just put this into priority queue. After that, after we use this, then it means all of the node pointed by this will be reduced by 1. That's why after that we need to put 1 and 4 to the priority queue. So since we want to find the lexicographical smallest, so we will use 1. And after use 1, we can use 4. After use 4, just reduce this to become 0. So put this into the priority queue, and then just output 3. Alright. So that is the idea how to find the lexicographically smallest in topological sort. Alright. But there is another thing that make this problem harder. What is it? So yes. So initially each item has serial number, and you know the serial number is changing in each days. Okay. So after 1 day, in the next day, the serial number is changing, become x plus d modulo n. Alright. That's why the serial number is always changing. Okay. For example, for this problem, so initially the serial number is like this. This is 0, 1, 2, 3. And the only option is we need to take this. Take the second item, which serial number is 1. After that, in the next day, the serial number is changing by 1. So increase it's not by 1, but in modulo n. So from serial number 3 becomes 0. Alright. Then which one is the smallest? How do you think? After we take this, there are two options between this and this. So which one we will choose? How do you think? Okay, yes. So we will choose fourth item, which the serial number is 0. After that, the serial number is changing again. So this become 2, and this is 3, 0, 1. So there are two options. We can take this or this. So how do you think? Which one we will choose? Yes, just choose the third item, which is the serial number is 0. After that, the serial number changing again become 3, 0, 1, 2, and we will take this. This is the last item. So the index is 3. Alright, this is the Lexio perfectly smallest. So can we use priority queue for this case? Yes, there is another solution other than only 3. So what is it? How to use priority queue to solve this if the serial number is changing? How do you think if the serial number is changing? So the priority queue storing what? Their value? Do you mean their serial number? It is the same. Either the changing serial number is only for for item that is not booked yet, or all item, it is the same, right? Because we don't care about the item that already booked. If we store their serial number, then what if the serial number is changing? What shall we do if the serial number is changing? For example, we will push in the first day after we take this, we will push 2 item, right? Which the serial number is 0 and 3. But after the next day, the serial number are changing, right? Become 1 and 0. So the top become this, not this. So how do you think? Can we handle it using priority queue? Then how to do that? Because from this become this. Salt we change them one by one. Maybe pop all of them and then push again one by one, or there is another case. Okay, all right. For salt we pop one by one and then push x plus n. Okay, so what if all the degree is zero in the first time? All of the degree is zero, so there is no edges here. And then g is equal to n minus 1. So what is the complexity for your solution? Since all of the degree is initially zero, so we will push all of them into the priority queue. How do you think? It's just like cyclic shift. Can we do cyclic shift in priority queue? What is the complexity for cyclic shift? Block n to open element. Alright, so how many elements we need to pop? Yes, and so, or maybe d is equal to n divided by 2. So it means we want to pop all of half of it and then push them again. Is it correct? What do you think? Yes, we can use set. Okay. Alternatively, we can use set, and we can create our own set using Fenwick tree, right? So we can use Fenwick tree or set. Yes. So just store all of the index of the item. Then what shall we do to find this smallest one? For example, in the first day, the smallest one is the set dot begin. But how about the second day and the other day? Okay. So actually, it is just like cyclic shift, right? So if in the first day, the smallest index, or sorry, the smallest serial number is in the first item, right? In the first day, the smallest serial number is the first number, which the serial number is 0. And then for the second day, how do you think? Which item has the smallest number? Or what is the smallest serial number for all items? Of course, since the formula is like this, so the serial number is still from what until what? Okay, yes. So the serial number is always from 0 until n minus 1, right? So in the first day, the serial number is from 0 until n minus 1. And then after we do this formula, the serial number is still from 0 until n minus 1, right? Because all of them added by n and then modulo by n. Sorry, added by d and then modulo by n. That's why the value is still from 0 until n minus 1. So the smallest value, sorry, the smallest serial number is always 0, right? But the index of the item is changing. If in the first day the index of item is 1, then what is the index item for the second day? What do you think? So serial plus, yes. So plus or minus. So if in the first day the serial number is equal to index index minus 1. So the serial number for the second day is index minus 1 plus d modulo n. Is it correct? So if we want to find what is the index of item, that is the serial number is equal to 0. So what is the index? So the index is congruent with t minus 1. Is it correct? T minus 1 modulo n. Sorry, 1 minus t, I think. If we move it on the right, become 1, and then move it on the right, become t modulo n. So it is just like, okay, n plus 1 minus t. So it is just like n plus 1 minus t. And then how about the next day? So after we add another t, means just change like this, right? N plus 1 minus 2t modulo n, and so on. So always use modulo n here. Okay. So, if the smallest serial number is this item, so what shall we do to find the smallest available item? Because this item is not always workable. So sometimes we still cannot buy this item. So that's why we need to start a set contain the value of its, the index of its item that we can buy for now. Right. For example, if we know that the smallest serial number is 7, so it means we want to find the next number after 7. Is it correct? For example, second item is, we can buy second item and then 5 item and then 9 item and then 12 item. So which item we want to buy? If now the serial item of 7th item is 0. So it means if the serial number of this is 0, so the next one is 1, and then 2, and then 3, 4, 5, and so on. Is it correct? So we want to buy this, right? Is it understood? Yes. All right. So that's why we want to buy this. All right. Is there any question? How to solve this? So can you implement the solution? Okay, maybe one of you can implement that idea. So we need graph, we need to store degree, and then we need to store a set of available items, and what else? So let's implement it together. So just implement it here. Maybe one of you or two of you can code together. Yes, to start the implementation from the input. The input format is like this. From nt and then the edge for its index. Yes. Okay. Okay. Yes. Or just for from when until n again. Okay. All right. So I think we need to find Okay, yes, we will change it later. Right. I think we can just store this into the set. We need set instead of vector because we want to find the next item after a specific index. So I think we need to do this. Is it correct? So if not agree, just insert it to the set. Then x is just lower bound or upper bound. Upper bound of course, all right. Yes. So I think initially this is 1 because in the first day the first item is 1. Yes, or just cost plus 1. We want to find the lexicographically smallest. So salt we use minus minus here. For example, in the first day, we want to find the lower bound of 1. It means it is the first number, right? So we want to output the first number, right? Not the other number. It just output the lower bound. Okay. So actually we can directly use this. Actually, we need to check auto like this. For example, auto iteration here, because we need to check what if the id is equal to set.n. Alright. If not equal to set.n, alright, so x is just equal to that value. But if st, sorry, it is equal to st dot n, what shall we do? X is equal to what? You know, the set is cyclic, right? Actually, the index is cyclic. So if we want to find the next value, yes, if there is no value greater than that, so just find from the beginning. Yes, all right. So finally, we got this. And we don't want to add with g, but n minus g. Actually, minus g, but we will modulo it with n. All right, then what is the output? Not id, I think, but directly use x, and then I think x minus cos or plus n minus cos modulo n. We can use that formula. How do you think? Or if you want to do this, okay, just x plus cos modulo n, right? Is it correct? Or we actually can just output it directly. Okay, but not that when we find the lower bound, just use n minus cos. Okay, yes, just n minus cos. All right, so let's try in the sample. All right, I think st dot size here. Wait, we forgot to pop this or erase this. Wait, 2013. I think not like that. All right, I think this is one index. The same. Okay, I think we should put -1 here because the index is 0 index. Okay. I want to try to output the value with the set. Okay, initially 1 and 3. Okay, so I think it is web tu dot pushback I plus 1, and then degree I plus 1 is equal to k. So let's try again. Alright, 2, 1, 4, 1, 3, 1. Wait, initially it is 2. Then the output should be 1, right? Two, 4, 3, 1. I think the index of item is correct. But okay, I think it is not G, sorry. This cost. Alright, now it is correct. How about the second one? Alright, the output just same. So is there any question for this problem? As usual, we can solve this using Fenwick tree as well. So when we insert it, we just like updating a Fenwick tree in index I. And also when we erase it, it means we decrease 1 for index X. And when we want to find the lower bound, then just use this. For example, you want to find the lower bound for X, then just find the prefix of 1 until X minus 1. What is the sum? For example, the sum is 3. So it means we want to find the fourth value, right? Because there are 3 values here. So we want to find the fourth. How to do that? Just use binary lifting. Just use binary lifting until this value. Alright. That's the solution if we use bandwidth tree. Alright. So I think we need to move to the other problem. I think we ever discussed about problem A until AB. I think you already solved it, right? Do you remember this or these two problems? Anyone remember this? Maybe the new one is problem C. Have you solved this? This is the newest problem from Ecuador. I think this is in this year and this month. Maybe just 10 days before now. This is a new problem. And the problem is like this. So given n contest and we will participate in that contest one by one. The first contest, the second contest, and so on until the end contest or the last contest. And then for each contest, if our current rating is between L and R, then our rating will be increased by 1. All right. So for example, the first contest, the value of L is 2 and then the value of R is 5. So if our initial rating is 3, then after this contest, our rating become 4. After that, for example, for the second contest, L and R is 1 and 3. So because the current rating is 4, then it is not changing. So just still 4. All right. And then what shall we do? What is asked in this problem? So given Q queries, for each query given initial rating, for example, the initial rating is X. Then after all contests, what is our final rating? All right. And X is around 100,000. So do you have any idea? What if N is just until N is only 100, but Q is so big. So what shall we do? Maybe X is also small, for example, just 1,000. Then do you have any solution for this? Yes, just pre-calculate all of the answer. So what is the answer when X is equal to 1? And then what is the answer if X is equal to 2? Yes, and the complexity is OXN. All right. And for each query, just output the answer. So the complexity is just O1. So the complexity is OX times N plus Q. All right. After that, what if N and X is big? Can we pre-calculate faster? How do you think? So maybe we can imagine when n is equal to 1. Then if we want to find the array of n's, do you see a pattern? If n is equal to 1 and then given a specific L and R. So of course, all of the value before L is so small, and then the next is increased. Yes, 10, 11, 12, 13, and then this is not changing, right? So just still 13, 14, 15, and so on. All right. So if we move to the next contest, if n is equal to 2 and the next LR is here, then what shall we do? Sorry, maybe L is equal to 5 and R is equal to 10. It means this is changing, right? 6, 7, but this is not 8, but become 9, right? And then 10, then 11. How about this? This is still 11. And the other is just same. So do you got any idea? Did you get any idea? Or did you get any observation from this? Can we do the operation faster? So for example, here we want to increase from L to R by 1. But after that, when L is equal to 5, R is equal to 10, we want to add from 5 until 9, right? In this, we want to add from 7 until 12. So what shall we do if we want to add them instantly? Yes, that's it. It's just like use prefix sum or prefix different. Just increase this by 1 and then subtract it by 1. Okay, so we can do this faster, right? So what is the complexity if we use this trick? What is the complexity of precalculation? SON or OX plus N. So do you mean like this? So given and Q, L, R, and then we have a perfect sum with size 500,000. Then we want to add this and reduce this. Is it correct? That we want to do perfect sum, right? All right. So what will be do if initial rating of I is I? So we store this. Is it correct? So after that, just input the query. So let's see. Let's try to input the samples from this. Really? The output is like this. How do you think? Is it correct? Where is the bug? So the correct output is 6, 6, and 8. Maybe let's try to output the prefix. So let's see. Is the prefix correct? So let's simulate this. Maybe we just need to consider from 1 until 5. Or okay, we can consider until 10. After the first contest, the value become like this, right? How about after the second contest? Become like this, right? After the fourth contest, become like this. And the other is the same, so I don't want to write this again. How about the last contest? So this become, so the final graphic sum should be like this, right? So why our graphic sum is different? So where is the bug? Anyone got any bug? Yes, okay. So let's change it. Alright, now the value become better. But is it correct? Is there any other path? The answer is still different, right? So where is the path? What if we don't use any prefix sum? So just use brute force. Is this correct? So it is just same, right? We use optimization or not, the answer is same. So it means the bug is not in the optimization, but in the idea or in the detailed implementation. So how do you think? How to fix this? So this is not for L until R, right? But from what? Yes, that's it. Yes, so it is just like we have to do this if Bj is greater than or equal to L and Bj is less than or equal to R, just add this. Okay, why it is still different? Okay, I think I'm correct. Wait, is correct or not? Yes, I think it is correct since we iterated from 1 and only until 9, right? Only the first value, I think. Okay, the output is correct, but our prefix sum is different. Or maybe I miscalculate this from 1 to 5 and then from 1 to 3, from 3 to 6. Okay, to 6 means, okay, yes, I think I miscalculate this. From 3 to 6 means we want to increase this. And then from 2 to 4 become like this, and then from 4 to 7 Okay. So yes, it is correct. All right. So how to optimize this? Is there any idea? Okay, yes, just use Fenwick tree. So the idea is still like the previous idea, which we will use prefix sum, and then just add the first value and then just subtract after the last value by 1. But we need to find the first value and the last value, alright? Yes, we want to find using binary lifting. So initially the prefix sum is 1. Yes, we are agree with that. So it means we want to update with 1 like this. And then how about the output? Do you know? We want to find the prefix, right? So it means just find the prefix of L like this. And then we want to increase with L and increase in L and R. Is this correct? What do you think? Okay, we haven't implemented the theory and update. So we can update using this. Also, we want to find the theory. All right. So actually, it is still not correct because actually we want to find, right? We want to find L, not just L, but find L. Just like using penalty. Yes. And we also want to find R plus 1. All right. How to find that? So it means we want to find the first value that is greater than or equal to L or greater than or equal to X. So just store the sum and the index and then just iterate from log -1 until 0. And for this problem, I think log is just 19. Yes, to the power of 19 is greater than X. and then just increase with this and just check like this. Okay. All right, is it correct? Why the answer is still different? Okay, so for find, you want to find the first value or first index, that is the sum is greater than or equal to x. The first value of this. So if there are some value that is equal to x, and then this is less than that, and this is greater than that, using binary lifting, we can get the greatest number that is still less than or equal to x, right? Sorry, only less than x. That's why it will be here, and then just return it plus 1. Why the output is still incorrect? Maybe let's query from 1 until 10. Okay, yes, I see it. We should increase this before L. Alright. So now it is correct. Do you know why? We should do this before this. Or if we want to do L first, please don't find L plus 1, but find L plus 2. But I don't think so. I think it is still correct when we do this first. Why? Because if we find L, if we update this, then all of the value greater than that is also updated. All right. Or maybe we can do like this. We want to find first and then update them. Okay. If we do this, then it is also correct. All right. You got it? So this is the solution for problem C. Is there any other question? And then how about the other problems? Have we discussed this problem before? And for problem E, maybe we already discussed this before. How do you think? Anyone remember about this problem? The problem is like this. Given n elements and q queries. The query are find the sum from L to R. So just like to a perfect sum from L to R. And then after we do all of the query, we want to find the sum of all of the query. So the sum of all sums like this. So this is the final value. And we are allowed to reorder the array. So from the initial array, we can shuffle this. We want to shuffle them in order to maximize the sum. So do you know how to solve this? Any idea? So let's see from this one. We want to find the sum from 1 until 2. And then want to find the sum from 2 until 3. Then the sum from 1 until 3. Then how to reorder this? Yes, that's it. Okay, so we can reorder like this. Why we put 5 here? Because the number of contribution is the biggest. This is the largest contribution in the second index. That's why I just put 5 in the second index. All right. So your idea is correct. We just want to find the contribution for each index. So when there is a query from L to R, it means from L to R contributed once. So just add 1 here and subtract 1 here. After that, do prefix sum. So no need to use Fenwick tree for this problem. So after we got the contribution for each index, so just sort this and also sort the initial array. and just prettily match them, the biggest with the biggest and the smaller with the smaller and so on, and the smallest with the smallest. All right, is it understood? So just try to solve this, and then how about this? If you ever solve this, we need binary lifting as well to solve this. If we use Fenwick tree, alternatively, we can also use segment tree. Okay, you have solved it. Maybe we have discussed it. Is it correct? So we can move to the other problem. And how about this? Do you remember about this problem? And Abdullah also solved it. Okay. So I think the last problem is 8. Okay, I think for this it is new. So the problem is like this. If there is an array, we can change the array become a Fenwick tree. Do you know? If the initial array is just 1, 1, 1, 1, then what is the Fenwick tree? Fenwick tree is just like we are storing Fenwick tree. So for its index k, k is consists of least significant bit of k. So it means index k storing from k until the least significant bit of k, or the elder define it as a function of low bit. Low bit means 2 to the power of something. So the biggest k, so that 2 to the power of k can divide it. Sorry, the biggest 2 to the power of k, so that 2 to the power of k is divide this, and k should be non-negative integer. All right. So if there is an array, fa means a Fenwick tree of array A, and ffa means a Fenwick tree of A. Is it understood? So f to the power of k a means from array A, we want to find the Fenwick tree of it, and then find the next Fenwick tree of it, and then the next Fenwick tree of it, and so on until k. All right, that is the problem. Sorry, the problem is like this. Given fk a, and we want to find what is a. All right. So it is just reversing the problem. We don't want to find fka, but given fka, and we want to find the initial array. So is the problem understood? All right. For example, given n and k is like this, and this is the final array. It means it is FA, right? FA is like this. What is A? A is just like this, right? Because if we want to make this become Fenwick tree, the array become like this. All right. How about this? K is equal to 2. And if the initial array is this, then the Fenwick tree become this. Because 2 is adding this, so become 3. And then 4 adding all of them become 10. And then 6 add this become 11. And then don't forget k is equal to 2. So just create another Fenwick tree, which is equal to this. This is just add 1 and 3 and then add 10, 3, 3, 1 become 17. And then add 11 with 5 become 16. All right, so if the initial array is this, if fka is equal to this, then the initial array is this. So is there any idea? Let's see if we want to find this. If we are still don't know what is the value of its array, so just make it A, B, C, D, E, F. Imagine this is the initial. Then what is the Fenwick tree of it? So the Fenwick tree of it become A plus B, C, A plus B plus C plus D, E, E plus F. This is FA. How about F to the power of 2 of A? So just do another one like this. And then we want to add all of them. 2A plus 2B plus, I think not 2A, but 3A. And then 2B, and then 2C, and then it's just E, and then this is 2E plus F. All right, this is the final array. So if A is equal to 1, all right, so now we know that A is equal to 1. How about this? 2A plus B equal to 4. And we know that A is equal to 1. So it means B is equal to 2, right? Then C equal to 3. How about G? G is equal to 17 minus 3 minus, sorry, yes, minus 4 and then minus 6. What is it? This 4. So D is equal to 4. And E is equal to 5, and then F is equal to 16 minus 2 times 5. So equal to 6. All right. Until now, do you have any observation or idea to solve this? How do you think? Do you see any pattern here? Fibonacci number, really? Okay. So maybe in order to find the next pattern, okay, yes, there is a relation between this and Fibonacci number. Because if we continue this, the next one is 3a plus b, all right? And then if we continue this, sorry, this is 3a plus, wait, I think yes, this 3a plus b, right? And then the next is 4a plus b, and then 5a plus b. So now you got the pattern, right? So it is just like a plus b. All right, and all of them are c. So for the odd index, the value is just same, never changing. Why? Because it is only storing that value itself. Yes, the lowest bit is equal to 1. That's correct. And for a value that the lowest bit is equal to, or least significant bit is equal to 2, then the pattern is just same like this, right? So just ke plus f, same, right? Using the same pattern. But how about when the least significant bit is equal to 4? So if we see this and add them all, so a become 7, 7, and then plus 3b, and then 3c plus d. Okay, what's next? 7 plus 4 plus 1. What is it? 7 plus 4 plus 1 means n plus 7 become 12. I think not plus 4, but plus, wait, I think this is 6, not 7. Why 4? Third list means this, right? This is 3, right? Because we add them, a plus 2a equal to 3a. And also this 3 plus 2 plus 1 equal to 6. And then 6 plus 3 plus 1 equal to 10. Alright, 10a plus 3b plus e, 4b, and then 4c and d, and so on. and this is 15, then 5B, 5C, and D, and so on. Do you see the pattern here? So this is just like KB plus KC plus D, right? Yes, this is linear, and then this is triangular. So just like C combination, sorry, K combination of 2, or K plus 1, K plus 1 combination of 2. Yes, all right. And how about an index that is the lowest bit is equal to 8? Do you see the pattern? I think from the previous index, which the lowest bit is 4, the pattern is just same, just like this. And then for this, it is just like constant. And then what else? How about the index that the lowest bit is 2? Maybe it is triangular. Is it correct? Because we want to add this, because this is always constant, and then this is the only value from this. I think it is different from here to here. So we need to find the contribution value from this to this. And how to find the pattern? Maybe just implement it, and so we can find the pattern easily. So for example, n is equal to 8, for example. And then we want to try from k equal to 1 until k equal to 5. And then initially, the contribution of n is equal to 1. Wait, maybe we can use two-dimensional array. So initially, the contribution from its value is that value itself. Then for its k, for its we do a function f, we will do this. Maybe we will iterate it from the biggest one to the least one. And then just iterate from this until the least significant bit. Or maybe from I minus the least significant bit of I until I itself. And just add the contribution. Alright, so BIK passed by BJK. So just see out the contribution value for n. For example, n is equal to 8. Since we want to find the pattern for 8. Okay, let's remove this. Okay, so for the value itself, it is constant, always 1. And then for the fourth value, the fourth value is linear. Okay. And then the next value is, or from this is also linear. What else? This one is also linear. And then how about this one? This one is triangular. And sorry, the triangular is here. And also this, because the depth is 2, right? So x is constant, and then 6 and 4 are linear, and then sorry, 7 is also linear. Why 5 is triangular? Because it is go down twice. Alright, and here just go down twice, that's why it is also triangular. But this is go down 3 times, that's why the pattern is different. Alright, do you got the pattern? So maybe this problem is for your homework, because it is already 11 o'clock, or 11 past, sorry, this is 12 past 15, so you have to go for lunch. So just solve this, just find the pattern, and then uh, solve this problem with the complexity of n log n. Alright, so good luck for your study, and see you again tomorrow. And let's close our meeting with praying kafaratul majlis. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi Muhammadin walhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.